All right, so the next ones we're graphing a parabola that is just in the regular form, not in standard form. If you were using a graphing calculator, that'd be easy one to punch in since it's solved for y. There's two different ways you can solve this. One way is to do completing the square. The other way is just using a little formula to find the vertex, which is the way I prefer to do it. And so they tell you that if you want to find the x value of your vertex, you're going to do minus b over 2a. And the a, b, and c are just like when you use the quadratic formula. So b would be 4, a would be 2, so I would have minus 4 over 2 times 2. And then I would simplify that, so I would have negative 4 over 4, which is negative 1. So when you make your table, negative 1 is going to be the middle value on your table. Then you want to do 2 points on each side of that. So 0, 1, negative 2, and negative 3. And then basically just putting your things in for x and solving. So I would do 2 times 1 squared plus 4 times 1 plus 7. I'd probably just grab my calculator and use my calculator, but since I've got ones, that's probably easy enough to do. 2 plus 4 plus 7 would give me 13, right? And then I'm going to do the same thing, only I'm going to put zeros in for my x's. So that would be 0, that would be 0, I would get 7. Then I'm going to put my negative 1 in. So 2 times negative 1 squared plus 4 times negative 1. Negative 1 squared would be 1 times 2 would give me 2 there. That would give me minus 4. So 2 minus 4 would be negative 2 plus 7. Gets me 5. Eraser just erases too much at one time. 2 times negative 2 squared plus 4 times negative 2. We should know it's going to come out to be 7, but we'll just double check to make sure it's working out right. Negative 2 squared is 4. 4 times 2 is 8. 4 times negative 2 is negative 8. And then plus 7. Hey, it does give me 7. So I know I'm on the right track. And then I've got to do my negative 3. 2 times negative 3 squared plus 4 times negative 3. Negative 3 squared is 9. 9 times 2 is 18. Minus 12 plus 7. 18 minus 12 is 6, and 6 plus 7, 13. I now have my 5 points that I can go ahead and plot. So 1 goes all the way up to 13. 0, 7. Negative 1, 5. Negative 2, 7. And negative 3, 13. And I have my parabola that looks something sort of like that. So if you look on the Alex explanation, this is probably the alternate explanation. If you go to the bottom of the explain page, sometimes there's extra explanations. So number 2, if we want to graph our parabola, first thing we're going to do is find the x value of our vertex. So we're going to do minus b over 2a. Our b value is going to be 12. Our a value is going to be 3. So I'm going to have minus 12 over 2 times 3. And so the x value of our vertex is going to be negative 2. So going up, negative 2, negative 1, 0, and down, negative 2, negative 3, negative 4. So if we start and put 0 in for our x's, we're going to end up with y equals 7, right? That would be 0, that would be 0. So we just get the 7 on the end. 0 is easy to do. If we put our negative 1 in there, negative 2. If we put our negative 2 in there, negative 5. If we put our negative 3 in, should get negative 2, and if we put our negative 4 in, 7. So, plotting our points, 0 over up 7, negative 1 is down to negative 2, negative 2 is at negative 5, negative 3 is at negative 2, and at negative 4 we're at positive 7. And if I could hit my dots, I'd have my parabola. So on the third one, if x is equal to negative b over 2a, we're going to put what in for b? 8, and what in for a?
Negative 1.
Negative 1. So if we simplify that, we would end up with 4. So 4, 5, and 6, and 3, and 2, or whichever order you want to put those in. So, darn, we don't have any zeros. If we put 6 in for x.
Negative 6.
Negative 6. Five in for x.
Negative 3.
4 in for x.
Negative 2.
3 in for x.
Negative 3.
And 2 in for x.
Negative 6.
Should look something sort of like that. 6, negative 6. 1, 2, 3, 4, 5, 6. 5, negative 3. 4, negative 2. 3, negative 3. And 2, negative 6. And this time our parabola flipped across the x-axis since we had the negative in front of our x squared. The next three, 4, 5, and 6, say finding the zeros of a polynomial function written in factored form. The zeros of your polynomial function is where x equals 0. If you put it on a graph, it'd be where you're touching the x-axis. So basically, you're going to take each of your factors and set it equal to 0. On this first one, since there's not a variable with the 2, there's really nothing to solve for, so I can ignore that that 2 is there. Here I would have x minus 3 squared equals 0 and x minus 4 squared equals 0. Now since the squared's on the outside, technically I would take the square root of both sides and the square root of 0 is 0. So if you have your exponent out on the outside, you can ignore that it's even there. Or you can solve it and you'd still get the same thing. So we're just going to solve each of those. So in this case, I'm going to have a positive 3. And over here, I'm going to get a positive 4. So 3 and 4 are my zeros. Now these ones are called double roots, or they have a multiplicity of 2. Since they have 2 to the second power, they really would occur twice if I wrote it all the way out. X minus 3 times x minus 3. So you may see those terms where they call it a double root if it's squared, or they'll just say it has a multiplicity of 2 since it would occur twice. So number 5, now on this one, you do have a variable with the 5, so I do set that equal to 0. 5x could equal 0, x squared minus 25 could equal 0, or x minus 7 would equal 0. So solving the first one, 0 divided by 5 is just 0. The second one, we have a quadratic expression, so we'd have to factor that one out. X minus 5 and x plus 5. And so we'd end up getting a 5 or a negative 5 with that one. And I didn't put the equal 0 on that one, but on this one, I'd have to add my 7. And so I have 4 zeros on this function. Normally, you have the same number of zeros as you have variables. This one counts twice, so I have a 0 here, 2 here, and 1 there. So, on the third one, if I'm going to solve that one, what should I do?
Divide by 3.
So if 3x equals 0 and I divide by 3, I just get 0, right? The next one,
Add 6.
you get 6. If x minus 6 equals 0, you add 6, so you get 6. And on the last one,
Um, 3 and negative 3.
no. You can't solve it because there's a plus sign in there, not a minus sign. So if you did try to factor that, we'd have to say x and x, since this is a plus, plus and plus, 3 and 3, and we'd get a plus 6 in the middle. We can't get that 0 in the middle. Otherwise, if you solve by taking the square root, you'd have an imaginary number. And so in this case, when it has the plus sign in there, you can't factor it. So you just get 0 and 6. Seven, 8, and 9, now they're just working their way sort of backwards. They want you to find the polynomial f of x degree 4, which means it has 4 zeros, and it gives you the following zeros. Well, if my answers are x equals negative 2, x equals 1, x equals negative 6, and x equals 0, when I solve these, I would have had to move these over. And so if negative 2 is an answer, my factor would have been x plus 2, right? If 1 is a factor, or 1 is an answer, then x minus 1 was my factor. If negative 6 is, then I would have x plus 6. And here, I could just have a plain x, I could have 2x, I could have negative 5x, just like those ones where we had the number right in front of our x. I just used the plain x. So, since we're writing our equation f of x, we're just going to have f of x equals x plus 2 times x minus 1 times x plus 6 times x. So number 8, we want to find a polynomial f of x of degree 5 that has the following 0. So, if negative 6 is my answer, my factor would have been
X plus 6.
x plus 6. If 0 is my answer, then my factor would have been,
X.
just plain x is good. If 5 is my answer, then my factor would have been
X minus 5.
x minus 5. And if 9 is my answer, my factor would have been
Minus 9.
x minus 9. Since it says it has a multiplicity of 2, I would add what to that?
2.
Sort of. It's going to be squared. Means I have that factor twice. Or I could write a second x minus 9. So I have 1, 2, 3, 4, 5, because that one occurs twice. Now normally on Alex, they won't stick the x right in the middle. They'll put it either in the front or on the end just because it looks prettier, but you can stick it in the middle. It's okay, it'll work. It just looks kind of weird smushed in there. So number 9, we want our polynomial of degree 4 that has the following zeros. And so our factors would be
x minus 7, x plus 2, x, x plus 1.
and that'd just be our answer then. And the next one, polynomial long division. Just like it sounds, we're going to do long division, sort of like we did it way back in 3rd grade, only now we're using variables. I'm going to take x plus 5, I'm going to divide it into 6x squared plus 37x plus 39. So what I'm going to do is basically divide this first term by this first term, or think about what times x would give me 6x squared. Well, if I divide an x out of there, I just need a 6x. What you should be able to do is take this times this and get this exact same thing. 6x times x is 6x squared. Now on my second term, it's probably not going to match up. 6x times 5 is 30x. Now what they're going to do is subtract, so I can cancel out that leading term. So this becomes negative, cancels that out. 37 minus 30 would give me 7x, and just bring down the plus 39 on the end. Then you're basically just going to repeat that. What times x gives me 7x? Well, I just need a positive 7, and since it's not my leading term, I need the plus sign there. So 7 times x is 7x. 7 times 5 is 35. But then I have to subtract, so I change my signs. Cancels out the leading term. I get a remainder of 4. So 6x plus 7 is my quotient. 4 is my remainder. Now if I wanted to check my long division, if I take my divisor times my quotient, x plus 5 times 6x plus 7, and add my remainder, 4, I should get what I started with here. So just for fun, x times 6x is 6x squared, x times 7 is 7x, 5 times 6x is 30x, 5 times 7 is 35, plus the 4 on the end, so I get 6x squared. 7 plus 30 is 37x, and 35 plus 4 is 39. Hey, checks out. So any of your long division ones, if you really want to check them, the divisor times the quotient plus the remainder. So number 11, we are going to take x plus 4 and divide it into x squared plus 10x plus 20. So what times our x would give us an x squared? Just a plain x. We're then going to multiply that out. So x times x is x squared. X times the 4 is 4x. We then subtract so that we can cancel out our leading term, and we would bring down 6x, and the plus 20 can come along. And then we basically just repeat that. What times our x will give us 6x? A 6. So a plus 6 goes up on top. 6 times x is 6x. 6 times 4 is 24. But then we have to subtract. So our remainder, -4. And you always know that it's your remainder once that what you have left down here has a lower exponent than this. So this is an x to the first, I'd have to have an x to the 0. If it was an x squared, I'd have to have an x to the first. So my quotient, x plus 6, my remainder, -4. last one on this page, 3x plus 5 and 18x squared plus 51x plus 35. So what times 3x would give me 18x squared? 6x. So if I multiply by the 6x, I would get 18x squared plus 30x. Then I have to subtract. So I'm going to bring down 21x plus 35. By the way, Alex is really nice. It's not going to give you anything that doesn't divide evenly. So if you're getting some weird thing, go back and check your work. What times 3x gives you 21x? 7. So plus 7 up on the top. If we multiply, we would get 21x plus 35. So our remainder can be nothing, right? 0. So quotient 6x plus 7 with the remainder of 0. So this one was pretty short because chapter 3 only had 8 topics, so I just divided them up 4 and 4.